Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Coding a 2D Game Engine in Java series. So in the last series what we did was we got texture batching working. We did not complete it though. We still have to fix one issue, which we will do at the beginning of this episode. But then after we fix that, we will start working on sprite sheets so that we can have one texture with multiple sprites on it that we can sample specific sprites from. So the approach we're going to take is a pretty basic one, but it will work and that's all that matters. So let's take a look at how we will be doing the sprite sheets and then we will actually code them. Like I said, before we actually code this, I do want to talk a bit about what sprite sheets are. I'm sure you all already know what a sprite sheet is. It's just a bunch of sprites jumbled into one texture. Think of like Minecraft's block palette too. All those jumbled in one texture, that's a sprite sheet. And so we can use these to our advantage because we can put multiple sprites into one texture, which is really nice. Now, how do we actually take advantage of this though? Well, remember how I said that in textures, this top left corner is actually 0, 1, this bottom left corner is 0, 0, the very bottom right is 1, 0, and the very top right is 1, 1. That means that every value in between is something between 0 and 1. So, if we want to find out what the texture coordinates for this specific Mario sprite is, so we have him right here, I know for a fact that these sprites are all 16 by 16 because I set up the assets. So I didn't make them, but I did set them up so that they would be all the perfect size. So how would we find out what its texture coordinates are? Well, we know that this bottom left coordinate is going to be 0x, but then it's going to be 16 for y because it's 16 pixels up. This is in pixel values, right? And 0 is the bottom left always for OpenGL. So we have to remember that. Now the top left would be 0, 32. Then the top right would be 16, 32. And then the bottom left would be 16, 16. So this is our values in pixel values, which we can get pretty easily. If we know the width of each sprite, and if there is like 1 or 2 pixel spaces between the up and the down, we can calculate this pretty easily. We just literally loop through. This would be 0, 0, then 0, 16, then 0, 32, so on and so forth until you get all of them. I think I had that backwards, but whatever. And then you would do the same. You would, once you reach the end, you just bring your x back to 0 and then start looping through again. And then you go back to 0 and then you start looping through again, and then you can get the coordinates for every single sprite. But our next step is to convert these to normalized range between 0 and 1. How do you do that? It's really easy. You just do 0 over the total sprite's width, the total texture, so this whole thing's width. And then you would do 16 over the whole thing's height. And then you would do a 0 over the whole thing's width and 32 over the whole thing's height. And so on and so forth. And what that's going to do is it's going to normalize these pixel values so that they are in a value between 0 and 1. And then we can use these as our texture coordinates. And we can subsample, we can sample specific portions of our texture and send that to our GPU just by sending different texture coordinates, and then it will sample from wherever we pass these texture coordinates in. So what we are going to do is basically, when we have a sprite sheet, we are going to say, okay, how many sprites do you have? Well, this has 26. What's each sprite's width? Well, it's 16. The sprite's height, 16. And then we can get the image data, so the texture contains the overall width and height of the texture. Then we can literally just say, okay, and then do you have any spacing? In this case, no, there's no horizontal spacing or vertical spacing. If there was, then we would say, oh, there's like 2 pixels for horizontal and 2 pixels for vertical. And you could have those be separate. I typically leave it the same because it's just easier. But yeah, and then we can use this data to just loop through and create a list of sprites that have each of these texture coordinates specifically for each sprite. And then we can say, okay, I want the 0th sprite, which we could call him or we could call him. I'm going to call it the top left corner. Then this will be the first sprite, second sprite, third sprite, fourth sprite, fifth, so on and so forth. And then this is how we can retrieve sprites. We no longer have to think about texture coordinates. We just ask for sprite 0 and it will look up whatever sprite 0 is, and then give you the appropriate texture coordinates and everything. So this is the approach we're going to take. It's going to make a little bit more sense in code, I think. So let's actually code this out and see how it works. Before we start coding the sprite sheets, let's go into our render and fix that one problem we had. Remember how I said that if we actually go over the amount of textures we have, right, we just keep adding textures? That's not good. We should have a limit. So inside of our render batch, what we're going to say is public boolean has texture room, which will tell us whether we have room for more textures. And this will literally just return the size of the textures is less than 8. And we want to return this. So we will say if we have less than 8 textures and then we still have some room, then we will say public boolean has texture. So we can check and see if we have a specific texture, and then we'll say text. And we'll just say return this dot textures dot contains that texture. And with these two methods, we can now make sure that we limit it when we are adding in sprites. So then up here inside of our render, when we go to add a sprite, as we're looping through, we're not only going to check if the batch has room, but then we're going to say sprite, actually texture, text equals sprite.getTexture. If text does not equal null, and this batch has the texture, or this batch has texture room, and then we can add it. And this should be grouped together because this is one logical grouping. So what we're saying is if this sprite has a texture and this batch has the texture, we can add it. Or if this sprite has a texture and the batch has some texture room, then we can add it. And there is one last or. What if the texture is null? Well, then we don't care. If the texture is null. So if the texture is null, then we don't care. We can add it regardless. And let's hit simplify and see what IntelliJ does for us. So I guess this logical if statement can actually be reduced to just if the texture is null, or we have the texture, or we have texture room. And that is equivalent. So I'm going to trust IntelliJ on that one. But basically all we're saying is if we can add this sprite to this batch, then we will add it. Otherwise, we will not. And we just check for textures. If we run it, we'll get the same exact output that we were getting last time. And you see that that is all working correctly. So now let's move on to sprite sheets. So in order to have a sprite sheet, we actually need the concept of a sprite. Right now we have the texture coordinates and the texture stored inside of the sprite render. Let's offload this so that they are actually stored inside of something called a sprite, which the sprite render has access to. So we're going to create a new class, call him sprite. And then we're going to say you can create a sprite using a texture. And we'll import that. And this sprite is going to have a texture. And this sprite is going to have texture coordinates, so text coords. Then we will say if you initialize it with a texture, we'll just say this dot texture equals the texture. And what are our texture coordinates? Well, we're assuming if they just pass in the texture, they want it to be the whole image. So we'll just give it the default text coords, which are these. So then we'll say, and text coords, this dot text coords equals those texture coordinates. Then we will have one more method, public sprite texture, and a vector2f array text coords. So then we will say, okay, if you know what the texture coordinates are, then you can pass them in when you're creating it, and we will just initialize it here. And so then we will just set it to whatever texture coordinates are passed in. Then we'll provide a couple of getters. So we'll just say public texture get texture, return this dot texture. And we'll say public vector2f text coords. And we will say, whoops, return this dot text coords. So this should offload everything. Then inside of our sprite render, instead of doing this, what we're going to say is return our sprite dot get text coords. And instead of saying return this dot texture, we'll say return sprite dot get texture, which should be good. Then up here, instead of initializing it with a texture right here, we'll say initialize this with a sprite. And instead of saying this dot texture equals texture, we'll say this dot sprite equals sprite. We will get rid of these two references because we no longer need them. And then instead of saying this dot texture is null, if we just want a color, we will say this dot sprite equals a new sprite. And for the texture, we will just pass in null, which we know we'll give it an null texture here, and then it will give it the default texture coordinates, which should give us feature parity to what we had just a moment ago. So if we run this, we should get the same thing, except it's going to say we are passing in a texture. So instead of doing this, we can just wrap this in new sprite. And we can wrap this one in new sprite. And it should work exactly the same. So if we run this one more time, we get the same image. Okay, so we didn't really change anything here, right? We just moved those into the sprite, and then we just said, okay, instead of the sprite render holding those specifically, it just holds a sprite and then returns the texture coordinates and texture from the sprite. What's this going to do for us? Well, this is going to make it so that we can be a little bit more flexible with our sprite chords and stuff like that. So let's use that flexibility now by creating another new class, and we're going to call this the Sprite Sheet. Now, what is the Sprite Sheet going to hold? Well, this is going to hold a texture, and this is going to be its texture. So this could be like the parent texture, the overall image, like I showed you in the drawing. Then it's also going to have a list of sprites, and this is going to be its sprites. Then when you're creating a sprite sheet, we're going to pass in all that information I said. You're going to want to know the texture that you are coming from. We're going to want to know how big is each sprite, the sprite width. We're going to want to know how big is each sprite's height. And then we are also going to want to know how many spaces, if you have spacing. Let's actually do number sprites first and then int spacing. So how many sprites are in this, and then what is the spacing? Do you have any spacing? And we will pass all that into the sprite sheet. Now, right now, our textures don't actually hold how big they are. We do get it because we get the width and the height here, but we're not holding it inside the texture. So up here, I'm going to say private int width and height, and we are going to store these. So if the image is not null, then we're going to say this.width equals width.get0, and this.height equals height.get0. Which means we got the width and the height already when we loaded the image here. So now we're just storing the width and the height so that we can later get it if we want to. So we'll just return this.width, and we'll say public int get height, return this.height. Now let's go back into our sprite sheet. So now we have a way to get the overall width and the overall height, and we have the texture, we have the sprite width, the sprite height, number sprites, and the spacing. So we have everything we need to create this list. So let's say this.sprites equals a new array list. We will initialize it to empty. This.texture equals the texture passed in. Then we're going to say int current x equals 0. So we're starting at 0, and we're going to start at the top of the image because we want the top left to be our 0th sprite, and so on and so forth, till the bottom right would be our last sprite. So we'll say current y is actually texture.getHeight minus the sprite height, which will give us the bottom left corner of the top left sprite. Okay, just think of that image, and it's the top left sprite, bottom left corner. And then we're going to say for int I equals 0, until I is less than the number of sprites, I++, we're going to loop through until we get all the sprites. And we're going to calculate all of those coordinates. So we're going to say float top y equals something, float top right x equals something, float left x equals something, float bottom y equals something. And this is going to be our normalized device, or normalized sprite coordinates. So remember how I said, well, this current y is actually the bottom y. This current x is actually the left x. So we can get those ones pretty easily. So we'll say left x is actually our current x over casting to a float the texture.getWidth, because we just need to divide by the width to get this normalized. And same thing with the y, it's just the current y over, I cast it to a float, and then we'll say get height, because we need to make sure this is normalized. Then for the top right, or the top y and the right x, we just need to add the sprite width and the sprite height to these values to get those, right? So we'll just say, okay, well the top y is just the current y plus the sprite's height over, and then we'll say float texture.getHeight. And we're going to say the right x is current x plus the sprite width over the float texture.getWidth. And this will make sure that we have all of these in normalized device coordinates and that they are correct. So now let's create our texture coordinates using these. We'll say vector2f text coords equals, and we're going to say new vector2f Actually, let's do this. We'll just copy from our sprite the normal. So this is what it normally is, and then we will copy these here. And we know that this is the right X, this is the top Y, and so on and so forth. So we'll just replace the ones with right X and top Y, and the zeros with left X and bottom Y. So we can say that's right X, this is right X, this is bottom Y, and then we can say this is bottom Y, this is top Y. We can say this is left X, and we can say this is left X. And then that should be the appropriate texture coordinates now. Then we'll just create a new sprite using this data. So we'll say sprite equals a new sprite, pass in the texture, which is this dot texture. We pass in the texture coordinates, which is the texture coordinates we just created. Then we'll add it to our list. Then we will increment our current X and current Y. So we'll say current X plus equals sprite width plus spacing. So we move it over so that we're on to the next sprite. And then if the current X is greater than or equal to the texture's width, then we know that we have reached the end of the texture. So we will move our current X back to 0. And then we will move our current Y down a sprite so that we start moving down the texture. So we'll say sprite height plus the spacing. And then that should make sure that we move across the entire texture. Now, one last function that we will want, which will be nice, is public sprite get sprite, and this will take in an index, and then we'll just say return this dot sprites dot get index, which will just return whatever sprite the user asked for from this sprite sheet. Now we want to add this to our asset pool because we only ever want one copy of our sprite sheets. So let's go into our utilities, into this asset pool, and we will create a couple methods. Because sprite sheets are so custom and we do need to create them ourselves, we're going to add a method to add a sprite sheet right here, where we will basically just take in a string, which is the resource name, and then we'll take in a sprite sheet, which is the sprite sheet. Then we'll just say file equals a new file resource name, and if not, actually we need to create a list to hold this to, or a map. So we'll say private static map from a string to our sprite sheets. This is our sprite sheets equals a new hash map. And then we can use this down here. We'll just say if not asset pool dot sprite sheets dot contains key, the file dot get absolute path. So if we don't already have this, then we will just add it. So we'll say asset pool dot add sprite sheet, and it's the file dot get absolute path is what we're going to use, and we will add that sprite sheet. So then we can create a very similar method, public static sprite sheet get sprite sheet, and we will take in the resource name here. And I'm just going to copy all this because it's literally the same. Then the one different thing we're going to do from what we've usually done is if we do not have it, instead of creating it, we're going to say assert false error tried to access sprite sheet plus the resource name plus, and it has not been added to asset pool. So we'll just tell ourselves, hey, you just tried to get a sprite from a sprite sheet that's not actually in the asset pool. And that will return just nothing. So then we'll say return asset pool dot get, actually dot sprite sheets dot get or default. And then what we're going to do is we're going to say file dot get absolute path, and the default value is null. So this will just ensure that if we are in release mode and we hit this assertion for whatever reason, it's not actually going to do anything. This is all going to get removed. So then if we are in release mode, it will just return a null value instead. If you wanted to be really safe, you could probably have a default sprite sheet that just has no sprites and would return like empty sprites that way, or like a pink sprite like Minecraft, so that if for some reason a sprite sheet gets corrupted or something, then instead of your game crashing, what would happen is they would just get those pink images instead. We're not going to worry about that for now. That's for the future. But now that we have this functionality, let's actually try and use it. So let's go back into our level editor scene. And when we are loading resources, we will say asset pool dot add sprite sheet. And I'm going to call this assets slash images slash sprite sheet dot png. I have that image located in my images folder now. Then I'm going to say this is a new sprite sheet. Actually, let's move to the new line. This is a new sprite sheet, and this takes in the texture. So we're going to say that's asset pool.get texture, assets/images/sprite sheet.png, and then we need the sprite width, which is 16, sprite height 16, the number of sprites is 26, and the spacing is 0. Then this will add the sprite sheet to our resources. Let's move this to the top of our init method. That way we load resources first. And then I'm going to grab that sprite sheet. I'm going to say sprite sheet sprites equals asset pool.get sprite sheet. And this is assets/images/sprite sheet.png. And now we can use this. So instead of saying this is a new sprite render, new sprite, all this stuff, we can just say this is a new sprite render and we are using sprites.getSprite0. And same thing down here. I'm just going to give it a random one, sprites.getSprite10. And so then this should get two different sprites located on the sprite sheet. And we're going to get an error. Oh, whoops. We called asset pool.add sprite sheet within add sprite sheet. This should not be happening. We should say asset pool.spritesheets.put. And then that should be good. Okay. Now if we run this, you notice we get two different sprites, which is pretty cool. And if we go into our level editor scene and we just change the index of this to 15, it instantly changes to a new sprite. And this is great because now instead of having to load individual images, we can just do this and then we can index into one sprite sheet very simply and get a much better variety pretty easily. So yeah, one thing you might think about trying to do is, oh, this is really cool. I'm going to try and inside of my update loop, just change the sprite on the object. And that way I get a little animation running. And that would normally work, but it's not going to in this case because we are not reloading this data every frame. And in order to do that, we need to add a dirty flag system to our batched render, which will probably be the topic of the next tutorial. So this batch render does take a bit to get it working properly, but once it does, it's super nice to have. So yeah, this was Sprite Sheets though. I hope you guys enjoyed this. If you did, please hit like and subscribe. In the next tutorial, what we are going to be doing is adding a dirty flag system so that we can update anything in our render batch that has changed. So I'll see you guys then. Thanks for watching.